Hello students, today we will dive more into probability. We are going to first look at something called the sample space, okay? So the set of all possible outcomes or of one or more events, so now we're going to be looking at multiple events happening at the same time, is called the sample space. Okay, so it's all the possible outcomes of one or more events. Okay, so it says you randomly choose a crust and style of pizza. Find the sample space. Okay, so when we do these, one way you can find the sample space is by making a tree diagram. So you see we could have two types of crusts. Okay, so the first thing I'm going to do is show that you could have a thin or a thick crust, or a stuffed crust, excuse me. Okay, but now with the thin, you can either have a Hawaiian, you could have a Mexican, you could have a pepperoni, or a veggie. Same with the stuffed. You could have a Hawaiian, a Mexican, a pepperoni, or a veggie. Okay, so the first row to this showed you the crust. Okay, so I'm going to just label this crust. And the second one showed you the style. Okay, so now that we made this tree diagram, we can list off all of we can name the sample space. Okay, so by doing that, we are listing off all the different types we can have. So we could have a thin crust Hawaiian, a thin crust Mexican, a thin crust pep, or a thin crust veggie. Okay, the double tick marks just mean repeat what's above if you've never seen that before, so repeating the thin crust. We could also have a stuffed Hawaiian, stuffed Mexican, stuffed pepperoni, or a stuffed veggie. Okay, so I know it's a little time consuming listing out all these different options, but when it says find the sample space, this is what it's asking for. So this is a sample space of the situation. So how many different pizzas are possible? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 are possible. Now it says, what if the pizza shop adds a deep dish crust? Find the sample space. Okay, so if it's adding this deep dish, that could now become a new crust. So we could just add on to our original tree diagram. So deep dish. And you could have all four again: Hawaiian, Mexican, pepperoni, or veggie. Okay, so the sample space would then include all four of these along with these 8. Okay, so that would make 12 possible different types of pizzas. Continuing on, this tree diagram can get really tiresome, especially when you have so many different options. Say they had 10 different crusts and 20 different styles. That would take forever to find how many different combinations pizzas there are possible. So there's something that we can use that is called the fundamental counting principle. Okay, so another way to find the total number of possible outcomes is the fundamental counting principle. So this says an event M and has little m options. Okay, so an event N has n possible outcomes. Okay, the total number of outcomes of event M, so some given event, so for example, the type of crust could be the M, followed by event N, so N could be the style pizza, is M times M. Okay, so you just have to multiply the two. So in the first example, we had 2 different types of crusts. So we would multiply 2 by the types and the number of styles, which was 4. And we would get 8 different possibilities, okay? That matches what we got in B. Okay, so it says we're looking at another example, moving on from the pizza now, in case you didn't like that or we need another one to make sure we understand. Okay, show 2 methods to find the total number of possible outcomes of rolling a number cube and flipping a coin. Use a table to find the sample space. Okay, so this table is already set up for our 6 options of rolling the cube and our 2 options of flipping a coin. Okay, so when you roll this cube, you could roll a 1. I'm going to do it in black actually. You could roll a 1, 2, 3, 4, 5, or 6. When you flip the coin, you could flip a head or a tail. That means your sample space is going to be all of the different options that could happen. So you could flip roll a 1 and get a head. You could roll a 2 and get a head, a 3 and get a head, and so on. But you could also roll a 1 and flip a tail, roll a 2 and flip a tail, roll a 3 and flip a tail, roll a 4 and flip a tail, roll a 5 and flip a tail, and roll a 6 and flip a tail. So this right here is our sample space, the total options. Okay? So we can count them up and see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different options. Or if we didn't need to find the sample space, all the different options, and we just wanted to know the number of possible outcomes, we could use that fundamental counting principle. Okay, so the first thing was rolling the cube, and that had 6 options. And the second thing was flipping a coin, and that has 2 options, a head or a tail. So when you multiply the 2 together, you get the 12 possible outcomes. We have one more example for today, which verifies that using this fundamental counting principle is so valuable, because now we have t-shirts, jeans, and shoes in this closet. Okay, so if you count very carefully, we need to look at all the different amounts of these clothings. Okay, so the first thing, we want to know how many different outfits you could make. We could make a tree diagram or a table for this, and there's 3 options, so probably just a tree diagram. But using the fundamental counting principle could be a lot easier. So first we need to find out how many t-shirts there are, so we should count. There's 1, 2, 3, 4, 5, 6, 7. Okay, so there's 7 t-shirts. We need to count the jeans now. They're on top. There's 1, 2, 3, 4 pairs of jeans. And there is 2, 3 different pairs of shoes. Okay, so all you need to do with the fundamental counting principle, all it says is that you have to multiply 7 times 4 times 3. So there's 2 ways you can do this. You can put 7 times 4 times 3 in your calculator and get out an answer, or you can break it down into parts, do 7 times 4, and then multiply that answer by 3. Either way, you will get 84 different outfits. Okay. We have one more option just to make sure, one more example just to make sure you understand this fundamental counting principle. Okay, so it says find the total number of possible outcomes of spinning the spinner, that's shown right here, and choosing a number 1 to 5. Okay, so if you spin the spinner, there are 4 possible outcomes, and if you choose a number 1 to 5, 1, 2, 3, 4, 5, there are 5 options. So 4 times 5 is 20. So you get 20 possible different outcomes. So today we looked at how to make a tree diagram, how to use a table to find the sample space, what a sample space is, and a good, easy way to find the number of possible outcomes by using the fundamental counting principle. Please let me know if you have any questions on today's lesson.